Another way to think about data in statistical analysis is to consider the different levels of measurement of data. We'll talk about 4 levels of measurement, and these are ordered from the lowest possible level to the highest. So we'll start with the lowest, and this is called the nominal level of measurement. Think of that nom part as connect that with the word name, because these are just names of categories. So they're just different categories that we might go out and do a survey and find out how many respondents were in each category. This data cannot be arranged in any particular ordering scheme. That doesn't mean you couldn't put them alphabetical, but there's no obvious way to arrange the data. So for example, hair color. Well, why would you put blonde before brunette or red? You know, you could alphabetize those, but other than that, there's really no rhyme or reason to the order of those. Or cereal preference. Say you've got the names of different cereals. Other than alphabetical, there's no reason to put Cheerios before Frosted Flakes, etc. So there's no particular order, and you're just collecting data and how much of your sample falls into, how many fall into each category. Lowest level, okay, these are, and when you think about our types of data, remember we had quantitative and categorical. Well, clearly this is a categorical data, type of data, and it is the most basic type, nominal, because it can't be ordered in any particular way. So stepping up to the next level, we're still talking about categories, but now there's a logical order to them. For example, t-shirt size. Well, generally, and it makes sense to list them small, medium, large, or there may be other sizes in there too, extra small, extra large, but they would be in a particular order that makes sense. It's not just alphabetical. There's an order to them. Or the Likert scale. That scale would be difficult to use if you had it all mixed up. We typically start, all the way on the left with possibly strongly disagree, to agree, to disagree, then maybe no opinion in the middle, then agree, and then strongly agree. But there's some order there. You would definitely put those in a particular order as you listed them. So that's just one more level. But again, both of these are categorical data. You can tell it says the word category right there in their definition. Stepping up to the next level, we have interval. Now you see that word quantitative or numerical. Now we're talking about numbers, but these are numbers that have no true zero. What does that mean? Well, there are not many data sets that fit that description. In fact, our book will only show temperature, I think, possibly date. By date I mean 1968, 1999, 2004, that type of date. Because when you think about temperature or date, 0 does not represent the absence of temperature or the absence of a place in time. 0 was sort of arbitrarily set. When that Celsius scale was created, what was considered 0 was chosen. It doesn't represent no temperature. Okay? So these are really the only 2 data sets that are commonly considered intervals. So that should make it pretty easy for you to categorize your data either in nominal, ordinal, interval, or the final one, because this one basically temperature and possibly dates. Okay, the last one then would be ratio, and this is really almost all the numbers we'll be dealing with. Now we're talking about numerical, right? The last 2 here are the numerical quantitative data, and there is a true 0, and 0 represents the absence of that characteristic. So height, 0 represents 0 height. 0 traffic accidents means there were none. So these are things we can actually assign a 0 to. Now notice under those, height would be a continuous measurement, because there are values between 1 and 2 and 2 and 3, right? We could have 4.78 inches if we were measuring the height of some fixture. Traffic accidents, we would not. That one is discrete. So I've given you examples of of both continuous and discrete under our quantitative or numerical data there. So levels of measurement from lowest level, the names of things, ordered categories, basically temperature, and then which is a number but has no true zero, and then all the other numbers we'll be dealing with in our statistical analysis.